Hi, this lesson is about the Cartesian coordinate system and the graphs of equations like lines, parabolas, as well as circles. So we start with the coordinate plane or the Cartesian coordinate system, also called the rectangular coordinate system, and that is defined by two axes, typically called the x-axis, which would be your horizontal line, and your vertical axis, which is the y-axis. That's what we typically called it. Those two lines divide up this plane, this two-dimensional space, into what we call four quadrants. And the first quadrant is in the upper right-hand corner here. And then you go counterclockwise. So then we have quadrant 2, quadrant 3, and quadrant 4. There are infinitely many points that make up that could be graphed on an xy plane. And those points are made up of an x value and a y value. So the x value defines the distance that you move horizontally, and the y tells you the distance that you move vertically. And where the two meet, that's plotted as a point. So when you are in quadrant 1, both of your x's and your y's are both positive because you've gone to the right. Those would be positive values of x, and you've gone up. And so where those two meet, you'd be in quadrant 1. When you are in quadrant 2, that means you would have gone to the left along the x-axis and up along the y-axis. So that means that your x values are negative and your y values are positive. Right in the middle is the coordinate 0, 0. That's called the origin. So anything to the right or left would mean that you're either going in a positive direction or a negative direction. When you go to the right, you're going in a positive direction. When you go to the left, you're going in a negative direction. When you go upwards, you're going in a positive direction. But when you go downward along the y-axis, you're in a negative direction. So that's why when I'm in quadrant 3, you've gone left and down. So both the x's and the y's are negative. And when you are in quadrant 4, that means you've gone to the right, your x values are positive, and you've gone down, and your y values are negative. So positive x values, negative y values, you are in quadrant 4. So understanding that is important so that you can plot points correctly and eventually plot the equations of lines, parabolas, and circles like we're going to do today, and get the right results. Okay, so here we're just going to practice plotting just points. So I want to plot the point 1, 3. So I've plotted that in green, 1, 3. And so that means you go 1 unit to the right and 3 units up. That's here in quadrant 1. The second point in red, negative 2, 1, means you've gone 2 to the left and 1 up. I'm in quadrant 2. The next one in this lighter blue color, negative 3, negative 4, means you've gone 3 to the left and 4 down. That's in quadrant 3. And the last one in this purple, 2, negative 5, is in quadrant 4. That means you're going 2 units to the right and 5 units down. That's your quadrant 4 point. So we just plotted 4 random points. You don't need to connect these in any way. So here we need to determine which quadrant each of the following points are in. So negative 3, negative 2, that means you've gone 3 to the left and 2 down. Negative 3, negative 2 is in quadrant 3. Positive 1, negative 5, that means you've gone 1 to the right and 5 down. That is in quadrant 4. Negative 1, positive 4, that means you've gone 1 to the left and 4 up. That would be in quadrant 2. So this is your quadrant 2. Okay. It is possible to have a point that lies on one of the axes, either the x-axis or the y-axis. And so here we want to state which axes each of these points lie on. So negative 1, 0, that means you've gone 1 unit to the left, but 0 units up and down. So if I've only gone to the left, that means I'm on the x-axis. 0, 8, that means you've gone 0 units left or right, but you've gone 8 units up. So that's going to be on the y-axis. 0, -7 is also on the y-axis because you've gone 0 units left or right, but you have gone 7 units down. 4, 0 means that you're going 4 units to the right, 0 units up or down, so you are on the x-axis. And 0, 0 is, again, the origin. That's right in the middle where the x and y axes meet, so it is on both of the axes. So notice that the coordinates on the x-axis have a y value of 0, but the two on the y-axis have an x value of 0. So that will be true no matter where they are on either of these axes. So if the second coordinate is a 0, you're on the x-axis. If the first coordinate is a 0, you are on the y-axis. Okay, so we can find the distance between 2 points on an xy plane by using something called the distance formula. We're going to call the first point x sub 1, y sub 1. Those are called subscripts, those little numbers in the bottom right-hand corner. That's distinguishing it as the first point. And the second point will be called x sub 2, y sub 2. So that's the second point. And the distance formula says that you can compute the distance between 2 points by taking the square root of the difference of the 2x coordinates and then squaring that difference, the difference of the y coordinates, squaring that difference, adding those two values together, and then taking the square root of that sum, and that will give you a computation for how far apart those two coordinates are on those 2 points are on a plane. So just get back to where I was. Okay. So here we want to also compute the midpoint of 2 points. The midpoint would be the middle of two values, right in the center of point 1 and point 2. So the midpoint, which I'm going to call x sub m, the m stands for midpoint, the x value of the midpoint would be the sum of the two x values divided by 2. It's basically the average of the x's in the first point and the second point. And the second coordinate would be the average of the y's. So the y value here and the y value there get added together and then divided by 2. The results, x sub m and y sub m, would be the midpoint. That would be the coordinates of the point that is right in the middle of two other points. Okay, so we're going to use these formulas to compute the distance and the midpoint between 2 points. So here we want to find the distance and the midpoints and the midpoint for the points -3, 5, and 2, 0. So we could think of this as point 1 and this one as point 2. And then we'll plot the points as well as the midpoint so you can get a visual of what that looks like. So I'm going to plug right into this formula here. And so that will be that d for distance is equal to the square root of the difference in the x value. So this is -3 minus 2 raised to the second power plus the difference in the y value. So that'll be 5 minus 0 also raised to the second power. So when you do that subtraction, you'll get -5 squared plus 5 squared. -5 squared is 25 and 5 squared is 25. So I have to take d is equal to the square root of 50. So the exact answer when you simplify it is that d is 5 root 2. That's without rounding. That's an exact computation. If you were asked to round it to a particular place value, you would then put the square root of 50 into a calculator and round it according to the directions. But if you're not told to round, always present an exact answer the way I did. So that's the distance between the 2 points. Now to find the midpoint, I have to take the two x values and divide them by 2. Add those up, divide by 2. So my x coordinate is -1/2. Do the same thing for the y value. Add the two y's and divide them by 2. So the y coordinate is 2.5. So my midpoint is negative a half, 2.5. So these are the two original points given in the problem. This is negative 3, 5, and this is 2, 0. And the midpoint, the middle between those 2 points, is the one that I just computed, this one right here, which is a half at 2.5. So you go halfway between 0 and negative 1 and then go up 2.5 units. So my picture might not be super accurate, but if you had like a grid with lines, it comes out more precise. Okay, so here's another one where we want to calculate distance between -2, -4, and 3, -3, rounded to the hundredths place. So notice that here the directions are telling us that we're going to round that distance computation to the hundredths place, which is 2 decimal places. Your final answer should have 2 decimal places in it. And then we'll compute the midpoint. So again, I'm plugging it into the formula. So it's the square root of the difference in the 2x coordinates, so that's -2 minus 3 raised to the second power, plus the difference in the 2y coordinates, so that's -4 minus -3 raised to the second power. So when you do that subtraction and you square those numbers, you'll get 25 plus 1, which is the square root of 26. So plugging that into a calculator, the square root of 26 rounded to the hundredths place is 5.10. So the distance between these 2 points is 5.1 units. That's how far apart they are. But now I have to compute the midpoint. So I'm going to add the 2 x coordinates and divide by 2. So the first coordinate is a half. Add the 2 y coordinates and divide it by 2, and so the second one is -3.5. So these are the coordinates of the point that is in the middle of the 2 original points. Okay, so now we're going to move on to graphing an equation, and we start with a linear equation. So this is the slope-intercept form of a line, y equals mx plus b, where the m is 2 and the y coordinate, or the y-intercept, is -3. That's the value of b. So to graph a line, there's more than one way to graph a line. And one option is just to plug in points. Plug in values of x, calculate the y's, and then you'll have coordinates that you can plot. You need at least 2 points to graph a line. Here we're going to be calculating 5 points, which is more than what you need to graph a line, but I wanted you to get that practice of computing the y values for any value of x. So I set up a table. These are all the x values that were given in the problem, and you compute the y values by just plugging in here. So the first one, the y equal to -7, you just plug in -2 where the x is, and that is -4 minus 3, and -4 minus 3 is -7. That's that value. And you would do the same thing for all the other values of x. And so I get all of the coordinates listed in this table: -2, -7, -1, -5, 0, -3, 1, -1, and 2, 1. All of those points then get plotted on your xy plane. So -2, -7, -1, 5, 0, -3, which is also a special point. It's called the Y-intercept because it's where it intersects the y-axis. Then the next point is 1, -1, and the last one is up here, 2, 1. Connect those points together in a line. We put arrows at the end because lines go on and on forever in both directions. And so those points are considered to be collinear because they all line up on the same line. And that line is 2x minus 3. Okay, so we'll do another one here. Here we want to graph y equals negative 3x plus 1. This is in the same format as the previous example. And these are the values of x that are given. So again, I set up a table, put all the values of x here. You plug in each x value one at a time into the equation. So here's the work for when I plug in negative 2. So I have negative 3 halves times negative 2 plus 1. This reduces down to just positive 3. And so you get a y value of 4. So that is your first coordinate, negative 2, positive 4, which is what is plotted right here. Then you do the same thing for the other points. When you plug in 0, you get 1. When you plug in 2, you get negative 2. When you plug in 4, you get negative 5. And so those points are plotted here on the right. Here's 0, 1. Here's 2, negative 2. That's in quadrant 4. And 4, negative 5 is also in quadrant 4. Connect these together in a line with arrows at the end. And there is the graph of the equation of the line negative 3 halves x plus 1. So notice that in this example that I just did, that the line is going down from left to right. And the previous example, the line was going up from left to right. The direction that the line goes in has to do with whatever this number is. That's called the slope of the line. In the first example in orange, the slope is positive, therefore the line goes up from left to right. And in this example, my slope is negative, therefore the line is going down from left to right. And that will be consistent anytime you graph the equation of a line in the slope mx plus b. The m will determine the direction that the slope is that the line is going in. Okay, this next equation is a quadratic function. And so the graph is not going to look like a line. It's actually called a parabola. It's going to look like a U. And similar to what I did with the line, I'm going to plug in the values given for x and compute the values of y. So all of those are listed right here. And I showed the work for when you plug in negative 2 right here. So it's y is equal to 1 minus negative 2 squared. So negative 2 squared is 4, but this minus still comes down. So it's 1 minus 4, which gives me an answer of negative 3. So negative 2, negative 3 is the first coordinate. So negative 2, negative 3. If you plug in negative 1, you'll get 0. If you plug in 0, you get 1. This is the Y-intercept, but it's also called the vertex of the parabola. That's going to be where the U changes direction. So in this case, it's an upside down U. So the vertex is where it goes from increasing to decreasing. If your U was in this direction, then the vertex would again be in the middle. So that's where it transitions from decreasing to increasing. So you plot all those points and then connect them in that U shape. Okay, so like I mentioned earlier, your linear equations can be in this form, which were the two examples I did, where m is the slope and 0b would be your y-intercept, but they could also be presented in this form, where your x's and y's are on the same side of the equation and you have a constant on the other side. When it's in that form, you can still graph the equation, but you won't be able to pick out what the slope is or the y-intercept. The quadratic function that we graphed, this is the general form of a quadratic function, and you can compute what the vertex is by using a formula, and that formula is what you see right here. The x coordinate is negative b over 2a, and the y coordinate is the function value at negative b over 2a. So you'd have to plug in this number in here for the x's, and then you'd be able to get the y coordinate, right? And the a, b, and c come from the equation. And like I mentioned before, the graph is a parabola. When your a, this number, is negative, your parabola is upside down. When your a is positive, your parabola is a typical U shape. Again, I mentioned intercepts earlier. So intercepts are points on a graph that intersect either the x or the y-axis. So you find x-intercepts when you replace the y with 0 and then you solve for x. Those are also called, x-intercepts are also called zeros or roots, and you'll hear those words a lot in this course. And y-intercepts, that's when you let the x equals 0 and you solve for y. So if I go back to this one right here, that was both a vertex and a y-intercept in this particular example. So when the x is 0, that's how you find your y-intercept. So here you're asked to find the x and y intercepts of this line. So this is a line in the form ax plus by equals c. And we just need to use these definitions in order to answer this. So we're going to find the x-intercept by replacing the y with 0. So that's exactly what you see here. So I have negative 6x plus 3 times 0 equals 18. So that gives me negative 6x equals 18. Divide both sides by negative 6. And your x-intercept is the point negative 3, 0. So when x is negative 3, your y is 0. To find the y-intercept, then I'm using this part of the definition, replace the x with 0. So again, plugging into that equation, I have negative 6 times 0 plus 3y equals 18, which leaves me with 3y equals 18. Divide both sides by 3, you get that y is 6. So when x is 0, your y is 6. So that is your y-intercept. And remember, if you had to graph this, all you really need are 2 points. And here I have them, 2 points. And I'd be able to come up with the graph pretty easily by just plotting those 2 points and connecting a line through them. Okay. To find the x and y intercepts, the vertex as well as the axis of symmetry for y equals x squared minus 5x minus 6, I'm going to be using the definitions and formulas that I gave earlier, and then we'll sketch the graph. So x-intercepts, I'm going to let the y equal 0. So this y gets replaced with 0. This is factorable. So this factors into x minus 6, x plus 1, which gives me two solutions, 6 and negative 1. And so these two numbers represent two x-intercepts, negative 1, 0, and 6, 0. Those are points on the x-axis that the parabola will go through. The y-intercept is found by letting the x's equal 0. So again, I take this equation, I replace the x's with 0, and you get that y is negative 6. So 0, negative 6 is where the graph will intersect the y-axis. So I have 3 points to plot so far. But you were also asked to find the vertex. And the vertex is when I need to use the formula that I mentioned a couple minutes ago. And that is that you can find the x-coordinate by plugging it into negative b over 2a. In this equation, the a is 1, that's the coefficient of x squared. The b is negative 5, the coefficient of x, and the c is the constant. So when I plug in here, it'll be negative 5 over 2 times 1, which is 5 halves. So that 5 halves has to get plugged into the original equation, and I think some of this may have been erased. So let me rewrite this. So this will be 5 halves squared minus 5 times 5 halves minus 6. So that gives us 25 over 4 minus 25 over 2 minus 6 over 1. I need a common denominator here, and that LCD is 4. So this fraction gets multiplied by 2 over 2. This one gets multiplied by 4 over 4. And now these three fractions can be combined together. So when you do, you get negative 49 over 4, which is the same as negative 12 and a quarter. So 5 halves negative 49 over 4 is the same as 2.5 negative 12 and a quarter. So seeing it as a mixed number makes it easier to graph it when we get to that part. All right, the axis of symmetry is a vertical line that goes through the vertex. So once you figure out this part, what the x-coordinate is of the vertex, the axis of symmetry is the same value. So the axis of symmetry is the line x equal to 5 halves or x equal to 2.5. Okay, so now we have to put this all together. The axis of symmetry I've drawn here in this navy blue color. It divides the parabola in half. The vertex is here below. This is negative 12 and a, I'm sorry, 2.5, negative 12 and a half. Remember, this is 3, so 2.5 is right between the two. And then I had my x-intercepts, my y-intercept is up here, 0, negative 6. And we had x-intercepts, which were 0, negative 1, 0, that's this one, and 6, 0, which is this one. So once you plot those 4 points, knowing that your shape is a U, you can put them all together and you get the graph of your parabola. It's an upward facing parabola because the leading coefficient is a positive number. If this was a negative number, it would be upside down. Okay, so now we'll talk about circles. So the equation of a circle comes from the distance formula, which we talked about in this lesson. So as a reminder, you can find the distance between 2 points by plugging it into that formula. Now, imagine if I call one of the points H and K, and that point is going to be the center of a circle. And if I call the other point, some point on the rim of the circle, XY. And if I plug in HK and XY into my distance formula and call it R for radius, then I would have that R is equal to the square root of x minus h squared plus y minus k squared. If I squared both sides of this, that would get rid of this radical. And so r squared equal to x minus h squared plus y minus k squared, that's considered to be the standard form of the equation of a circle, where the center is at hk and the radius is r. So if we have an equation of a circle that looks something like this, we can easily pick out what the center is and what the radius is. And both pieces of information will then make it possible for you to graph the circle. Remember, the radius is just the distance from the center to any point of the circle, which is why it makes sense that we were able to use the distance formula here. Okay, so here I want to identify the center and the radius and sketch the graph. This is an example of one that's in exactly this form. So the center would be 1, 3, the opposite signs of these two coordinates. And the radius, remember here it's r squared. So if this is r squared, my radius is 2. And if you were to graph this, now the graph isn't going to look exactly like a circle because this is done freehand. What you do is you plot the center first, which is the point in purple. So I went 1 to the right, 3 up. And then I counted 2 units, north, south, east, and west, or up, down, right, and left. Okay? So if you count 2 units up, I'm at 1, 5. 2 units down, I'm at 1, 1. If I go 2 units to the right, I'm at 3, 3. And if I go 2 units to the left, I'm at negative 1, 3. And those 4 points plotted on the outside of the circle is what will allow you to then connect those 4 points and create your shape. Again, it should look like a perfect circle. That's pretty difficult to do freehand, but it's what it's supposed to look like. All right, then part B is similar. It is in the format of the equation above, so I have x plus 2 to the second power plus y plus 1 to the second power. The center will be the opposite sign of these two numbers, -2, -1, and the radius is the square root of 9, which is 3. Plot the center first, that's in purple, and then count 3 units in each direction, up, down, right, and left. And you get the 4 points on the outside. Connect the 4 points on the outside. Never connect the center. Only connect the 4 points, and there you have your circle. Okay. In these exercises, we're going in the other direction. You're given the center and the radius, and you're going to state what the equation is. So that means we need to remember that the equation has this form: x minus h squared plus y minus k squared equals r squared. Okay. So that's going to be x minus -3, which is x plus 3 squared, plus y minus 4 squared equals 1 squared. So your equation is what I circled here. For the second one, the center is at 2, 0, and the radius is 4. So when I plug it into this formula, it's x minus 2 squared plus y minus 0 squared equals 4 squared. So your equation is x minus 2 squared plus y squared equals 16. Okay, so when the equation of the circle is not given in standard form, meaning it's not in this form, there is something we can do about it to help us figure out what the center and the radius is. In other words, put it into standard form. And that method is called the completing the square method, which you've probably done in an algebra class, but if you haven't, we'll practice it here. So this is the original equation. And it certainly doesn't look anything like these that I did before. So we need to make it look more like the format above. So the first thing I did was I reorganized that equation. I put the x's next to each other. So I have x squared minus 6x. Then I left some space. Ignore that orange plus 9. Then I put the y terms together, so I have plus y squared plus 4y. And again, I left some space, so ignore that plus 4. And I moved the constant over to the right side, and you can ignore these for now. Okay, so what you see in orange, that's the completing the square part. You take half of the coefficient of x, which is -6, and you square that number. So -3 squared gives me 9. And that 9 gets added to both sides of the equation, right? Keep the equation in balance. Whatever you do to one side, you do to the other. Then I do the same thing with the y coordinate. So half of 4 is 2, and when you square it, you get 4. So you add 4 to both sides. When I do that, I've created two perfect square trinomials, which means that these two trinomials will factor in a very specific way. It's the same factor twice. So that factors into x minus 3 squared, and this one here factors into y plus 2 squared, and these numbers collapse to give you 11. So if you're asked what is the center and radius of the circle, this one is now in standard form. The center is at 3, -2, and the radius is the square root of 11. Okay. Here's another one. We want to identify the center and radius, and then we'll sketch the graph of x squared plus y squared plus 14y plus 13 equal to 0. This one's actually a little bit easier because I only have an x squared. I don't have an x term, so I'm not going to have to complete the square on both of them. So all I did was I moved the 13 over to the right. I took half of 14, which is 7. half of 14 is 7, and then you take the 7 and you square it. And that's the number that gets added to both sides of the equation. That then leaves me with x squared plus, and this whole thing factors into y plus 7 squared equals 36. This is now my equation in standard form with a center at 0, -7, and a radius at 6. And that's what it would look like. The center's here in the middle in this purpley pink color. You count 6 units up, that's at 0, -1, down, that's at 0, -13, to the right, that's at 6, -7, and to the left, that's at -6, -7. And connect the 4 points on the outside and you have your circle. Okay, so here we're going to combine a couple of concepts that we've done in this lesson, which says find the equation of the circle with a center at 3, 4 that passes through the point 5, 7. So we need to find the equation of a circle. I don't know what the radius is, but I can certainly figure it out by using the distance formula and compute the distance from 3, 4 to 5, 7, because 3, 4 is the center and 5, 7 is on the circle. So once I figure out what that radius is, I'll be able to use the equation for the standard form of a circle and come up with the equation for the numbers given. So first find the distance. Remember, the distance is the radius. And so that'll be 5 minus 3 to the second power plus 7 minus 4 to the second power, and you take the square root of that whole thing. So that is 2 squared plus 3 squared, that's 4 plus 9. So the radius is the square root of 13. So now we use that and the center. Remember, the center is 3, 4, and this is now my radius, and plug it into the formula. So that'll be x minus 3 to the second power plus y minus 4 to the second power equals the square root of 13 squared. And so your final answer is what you see here in the box. Okay, so that's it for that lesson. Good luck.